2 and example 3. I'm going to teach you how to work with inverse functions if they're not much indirect function, how to open the expression. Well, let me start. Example number 1, sine of tangent inverse of 1/2. So usually question is how to calculate this. If it was sine of sine inverse, we know that they just cancel. If it was tangent of tangent inverse, we know that they just cancel. But what to do when sine and tangent are mixed up? Well, first we're going to turn on the logic and think, okay, tangent inverse returns back the angle theta. So that's actually tangent of theta equals 1/2. Now, if it returns back theta angle, then sine of this angle is going to be whatever we are searching for. So, problem actually looks like this. Tangent is given, sine is to be calculated. We do know how to solve these problems using Pythagorean identities, right? So, that's what I'm going to do this. I'm going to calculate, from tangent I can calculate secant, which is going to be cosine, and then I can calculate the sine. Or, well, we can try to do it a different way. I think that's one of the best way, actually. Identity. 1 plus tangent square of theta equals secant square of theta, which is going to be 1 plus 1 over 4 if I square 1/2 equals secant square of theta. Or, if I bring it to common denominator and then extract the square root of both sides, I'm going to get plus minus square root of 5 over 2 equals a secant of theta. We do remember that secant is not what we need. We need a sine. Secant is going to actually give us cosine. So I'm going to write down over here that cosine of theta is plus minus 2 over the square root of 5. Well, to calculate sine, we actually can use Pythagorean identity with tangent, but first we'll need to choose plus or minus. How are we going to do it? We are going to draw a circle. We do know that tangent is positive here, right? Tangent is positive here and here. We do know that tangent by itself, tangent inverse, is going to only return angles from negative pi over 2 to pi over 2. So not much option actually. Our angle is going to sit here, and the cosine here is positive, we remember, so we are going to use plus. So we have cosine of theta equals 2 over the square root of 5. Now, I do know tangent, and I do know cosine, I can find the sine. I'm going to use Pythagorean identity for it. Well, I don't know if I have still room over here. I think I do have. So I'm just going to write down that tangent of theta, which is 1/2, equals sine of theta, which is unknown, over cosine of theta, which is actually known, and 2 over square root of 5. So I'm going to put sine here and 2 over square root of 5. Now, I definitely don't have any space here. I'm just gonna jump over here, okay guys, and finish my problem over here. So I'm going to multiply by 2 square roots of 5 this one, so that's gonna be 2 square roots of 5 multiplied by 1 over 2 equals sine of theta. 2 cancels, and I have 1 over square root of 5 equals sine of theta. That's going to be my final answer, which answers the question of the problem. Okay, that's how we are going to solve a problem like this. So now I'm going to consider one more example. We combined here tangent and sine. Now I'm going to combine something like maybe sine and cosine to show you the difference. Okay? So, let me erase this. If you still copying it or watching it or doing like working on it, you can always stop my video and finish copying and then continue watching the next part. So, now I'm going to consider my second example, example number 2, and that's going to be cosine of sine inverse of negative 1. Cosine of sine inverse of negative 1. As usual, I'm going to write down that sine of theta equals negative 1 over 3, and cosine of theta is going to be a question. That's roughly how the problem sounds. Well, here everything is simple. Pythagorean identity: sine square of theta plus cosine square of theta equals 1. I'm going to plug in this 1 over 3 here, and that's going to give me 1 over 9, right? Because I'm squaring it, plus cosine square of theta equals 1. From where cosine square of theta, 1 minus 1 over 9, which is 8 over 9. Or cosine without a square is going to be plus minus the square root of 8, and the square root of 9 is 3. So we just need to choose which one we are going to use, and that's going to be the final answer already. Well, I'm going to draw a little circle. I remember that sine works from over here, from negative pi over 2 to pi over 2. This sine inverse returns back values from negative pi over 2 to pi over 2. Negative sign, that's negative y, means that we are going to be somewhere here. What is cosine there? Well, we do know that cosine is plus and plus, right? So we are going to use positive value for cosine. Cosine of theta equals the square root of 8 over 3. And again, we are choosing positive because sine is negative over here, but cosine is positive. We don't consider these two parts because sine inverse range is from negative pi over 2 to pi over 2, so only over here. Okay? And I think what we can do, guys, I'm going to write down the next example on the board and ask you to try it on your own for like 5 minutes, maybe 10 minutes, depending on how long you need. And then start video and see how I do it. And that's going to be our last example from this section. I'm going to erase this. And again, if you are still copying, still need it, just stop, pause the video, copy everything, and you can continue watching the video. So, example 3. Tangent of cosine inverse of negative 1 over 3. I want to make a little pause, like 3 seconds, and then I'm going to start solution. During this pause, I want you to make your video stop and try to do the problem on your own, similarly I was doing. Okay? So, 1, 2, 3. Now I'm going to do solution, and you can compare your solution in your own. So here I have cosine of theta equals negative 1 over 3, and the question is, what is tangent of this theta? Well, you see tangent and cosine are giving me definitely Pythagorean identity. 1 plus tangent square of theta equals secant square of theta. I don't have a secant, but I do know that cosine is inverse of secant. So from cosine, I know that secant of theta is going to be minus 3. I proved it already. Now I'm going to just substitute tangent square equals negative 3 squared is 9, or tangent square equals 8. Minus 1 here, or tangent itself equals plus minus square root of 8. Okay, now, which one should I choose, plus or minus? Again, a circle is going to help me. The cosine inverse is defined from 0 to pi, over here and here. The cosine itself is positive here, and negative here, because we are given negative cosine, meaning that we are sitting somewhere here. What is doing tangent here? Well, I'm going to use red color for tangent. Tangent is going to be plus, minus, right? That's tangent. Because it's minus here and a minus here, we're going to just use a negative sign for tangent. Final answer is going to be negative square root of 8. You can also represent it as minus 2 square roots of 2, because 8 is actually 2 multiplied by 4. You extract the square root of 4, it's going to give you this 2. Okay, that's the last example from this section. We are not going to do the whole section. I think that's enough for us. What you can do, guys, you can do all the homework on sections 2.1 and 2.2. And I think that's going to be enough for our Monday's lecture. And for Wednesday's lecture, I'm going to put more videos on my website. If you have questions, if something is not clear, not visible, not working, let me know through email, okay? I'm still kind of finding out how to make a very good communication with you. Okay, thank you very much.